Good morning, students. Today we shall be studying about the coordination compounds. In the study of transition metals, we have already learned that one of their important characteristics is to take part in the formation of complex compounds. These are also known as coordinate complexes or coordination entities according to the IUPAC system. So, after the end of this chapter, you'll be able to define the coordination compounds. You'll be able to explain the Werner theory, learn the basic terminologies. You will be able to differentiate between the double salt and the complex compound. You will be able to understand the nomenclature of the coordination compound. You will be able to describe isomerism in the coordination compound. And even you will be able to understand the valence bond theory and the crystal wheel theory and bonding in the metal carbonyls. Transition metals form large number of complexes. It forms large number of complex compounds in which metal atoms are bound to a number of anions or the neutral molecules. In modern terminology, such compounds are known as coordination compounds. Chlorophyll, hemoglobin, vitamin B complex, all are the coordination compounds. Variety of metallurgical processes, industrial catalysts, and analytical reagents involve the use of coordination compounds. Coordination compounds also find many applications in electroplating, textile dyeing, and medicinal chemistry. But we should know what is coordination compound. It's a complex compound, a special type, a special class of the complex compound in which the central metal atom or ion is bound to number of anions or neutral molecules. In modern terminology, these compounds are known as coordination compounds. Coordination compounds or complex compounds are a type of addition compounds. These compounds are mainly formed by the transition metals. And here I want to discuss about the electronic configuration of fourth period transition metals. Like in scandium, you can see there is a one unpaired electron. In titanium 2, vanadium 3, chromium 6, manganese 5, iron 4, cobalt 3, nickel 2, copper 1, and zinc does not have any free electron. It means unpaired electron. Now, Werner's theory. Werner in 1898 proposed his theory of coordination compounds. The main postulates are, what are the main postulates of the Werner theory? First is in the coordination compounds, metal atom exhibit two type of linkages. One is primary and second is secondary. It is linkage, or you can say that these are primary and the secondary valencies. The ligands attached to the primary valencies are ionizable and they represent the oxidation state of metal. The ligand attached to the secondary valencies are non-ionizable and these corresponds to coordination number. Every metal has a fixed number of secondary valencies because of its coordination number is fixed. So it means that the primary valencies are normally ionizable and are satisfied by the negative ion. Secondary valencies are non-ionizable and these are satisfied by neutral molecules or negative ions. The secondary valency is equal to the coordination number and is fixed for a metal. The ion or group bound to the secondary linkage to the metal have the characteristic spatial arrangement corresponding to the different coordination number. Such spatial arrangements are known as polyhedron. The polyhedron can be octahedral, it can be tetrahedral, it can be trigonal, bipyramidal also. Now, before we start this chapter, there are some important terms which you should know. So, first is the coordination entity. What is coordination entity? The coordination entity is the it's you can say that a coordination constitute a central metal atom or a ion bounded to a fixed number of ions or the molecule is known as a coordination entity. It is written within the square bracket. So here I have shown FeCN6 and the charge is -4. Next is central atom or the ion. What is central atom or the ion? In the coordination complexes, the metal ion or the ion to which a fixed number of molecules or ions are attached by coordinate bond is known as the central metal atom. In the above example, iron is a central metal. Next is the coordination number. Coordination number of a metal ion in a complex can be defined as number of ligands or the donor atom attached to the metal directly by the coordinate bond. Next is coordination sphere. The central metal atom and the ions or the ligands attached to it and enclosed in a square bracket is collectively termed as the coordination sphere. Ionizable groups are written outside the bracket and it is known as the counter ion. Now, what are ligands? Ligands are the electron donor molecules or the ions, which may be either neutral or anionic and linked to the central metal atom or ion by the coordinate bond. They are also known as the Lewis base because they are electron donor. And sometimes these ligands are also known as dentates. So ligands are of different type like monodentate, bidentate, tridentate, tetradentate, or I can say the polydentate. So first of all, monodentate. Monodentate means that it has only one donor atom. Only one atom can donate its electron to the central metal atom. So it is monodentate or it is also known as unidentate. Example is water, CN, NH3, NO2, OH, halides. And then is bidentate. In bidentate ligands, there are two donor atoms and have ability to link with the central atom or the ion at two positions. And the example is oxalate ion and ethane 1,2-diamine. Then is polydentate, a ligand with more than two donor atom is known as polydentate or multidentate ligand. For example, diethyl triamine or you can say EDTA. EDTA is what? It is ethylene diamine tetraacetate. Oxidation number of the central metal atom. Oxidation number of the central atom is a complex in a complex is defined as the charge it would carry if all the ligands are removed along with the electron pairs that are shared with the central metal atom. The complexes can be homolaptic or it can be heterolaptic. Homo, as the name indicating same. In homolaptic complexes, all the ligands are of one kind. It means all the donor groups are of one kind. And in heterolaptic complex, the ligands are of more than one kind. Coordination polyhedron, the spatial arrangement of the ligands atom which are directly attached to the central metal atom or the ion defines a coordination polyhedron about the central metal atom. The most common coordination polyhedra are octahedral and square planar. Thank you.